Let's look at the next tool in chain, Git. What is Git? Git is a distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Created by Linus Torvalds in 2005 for the development of the Linux kernel, Git has since become the most widely adopted version control system for software development and other version control tasks. It allows multiple developers to work together on a project, tracking and merging file changes and ensuring that conflicts between concurrent modifications can be resolved. Git operates on the principle of repositories, which are complete databases of a project's history. It tracks changes to a project over time by taking snapshots of the files, which are then committed to the repository. Developers can branch off the main project, creating a branch, work independently, and then merge their changes back into the main project main master branch, facilitating collaborative work without overriding others' contributions. Git's architecture and features have led to its adoption by countless individuals, projects, and organizations worldwide, making it a critical tool for modern software development. What to expect in the Git interview? When preparing for an interview focusing on Git, it's essential to cover both the practical usage of Git commands and a deep understanding of its principles, workflows, and problem-solving techniques. Here's an in-depth look at the areas you should be familiar with. 1. Basic Git operations. Initialization and cloning. Understand how to create a new Git repository Git init and clone an existing repository Git clone. Basic commands. Be fluent in Git add, Git commit, Git push, Git pull, and Git fetch. Know how to check the status of your repository with Git status and view the commit history using Git log. 2. Branching and merging. Branch management. Know how to create, list, rename, and delete branches Git branch, Git checkout, Git switch, Git branch D. Merging. Understand how to merge branches Git merge and resolve merge conflicts. Be familiar with different merging strategies and when to use them. Rebasing. Explain the concept of rebasing Git rebase, its advantages, and how it differs from merging. Know how to solve conflicts during a rebase. 3. Advanced Git features. Stashing. Understand how to use Git stash to save uncommitted changes temporarily. Cherry picking. Be able to cherry pick commits Git cherry pick from one branch to another and understand the implications. Tagging. Know how to create tags Git tag for marking specific points in history as important, typically for release versions. 4. Undoing changes. Reverting commits. Understand how to revert changes using Git revert and the difference between Git revert and Git reset. Resetting. Know how to use Git reset to undo commits, including the differences among soft, mixed, and hard options. Reflog. Be familiar with Git reflog to recover lost commits or to undo complex changes in the repository history. 5. Git internals. The .git directory. Understand the structure and contents of the .git directory, including what information is stored in objects, refs, the index, and the head. Git objects. Have a good grasp of Git objects blobs, trees, commits, and tags, and how Git uses them to represent repository history. The 3 states. Be clear on the concept of the working directory, the staging area index, and the repository itself in Git's architecture. 6. Workflow strategies. Feature branch workflow. Understand how to use feature branches for development and how they fit into the development lifecycle. Git flow. Be familiar with the Git flow workflow, its branch structure, and where it's most applicable. Forking workflow. Know how the forking workflow operates, especially in open source projects, including how to manage upstream repositories and pull requests. Chunk-based development. Understand the principles behind chunk-based development and how it encourages shorter-lived branches and more frequent integration. 7. Collaboration and best practices. Pull requests. Be able to explain how to create and manage pull requests, review code, and merge changes in platforms like GitHub, GitLab, or Bitbucket. Code review practices. Discuss the importance of code reviews in a collaborative development environment and how Git facilitates this process. Commit messages. Understand the importance of meaningful commit messages and how to write them effectively. 8. Problem solving with Git. Handling large files. Know about Git LFS large file storage and when to use it. Reducing repository size. Be prepared to discuss strategies for reducing repository size, including Git GC, removing old files, and dealing with binary files. Recovering lost work. Understand how to recover lost commits or branches using commands like git reflog and git fsck. 9. Security in Git. Signing commits. Be aware of how to sign commits with GPG to verify authorship. Managing credentials. Understand secure ways to manage credentials, including credential caching and SSH keys. 10. Tooling and integration. Git hooks. Know about Git hooks and how they can automate certain tasks within the Git workflow. Integration with CI/CD. Understand how Git integrates with CI/CD pipelines, triggering builds, tests, and deployments based on Git actions. Preparing for a Git-focused interview requires a balance between understanding the command line usage and the theoretical underpinnings of Git. Be ready with examples from your experience of applying Git to solve problems, collaborate with teams, or improve the development workflow. Demonstrating a deep understanding of Git's capabilities and best practices will set you apart in a senior DevOps engineer role. Thank you for watching the video. If you liked it, please don't forget to subscribe to the channel. For more content like this, check out my book, Cracking the DevOps Interview.